Welcome to the walkthrough for assignment 1B's frequently made mistakes. First and foremost, please don't remove the to-do tags. I use these to be able to quickly review your solutions, and if you remove them, it makes it much more difficult for me to review them in a prompt way. And when you've got 40-some things to review, it gets really very tedious to have to search through each file one at a time. So from now on, if you don't keep the to-do tags, I'm just not going to review your code, so please make sure you do that. Let's start talking about some of the problems I saw. First problem here really isn't a mistake, it's just something you don't have to do. There's no need to set msize equal to 0 in the constructor for unsynchronized array because fields that are integers are automatically set to 0 by default. So you can do it if you want to have a belt and suspenders approach, but it's not necessary. Let's now go ahead and take a look at some of the problems with the unsynchronized array constructor that takes a collection. So keep in mind that we don't need to check whether C equals null. This is done here with if C equal null. That's the right check. This check is redundant and will probably crash if C in fact equals null because calling the equals method through a null reference is likely to cause problems. There's also some additional work here that's not needed. You don't need to have this special case check. That'll just kind of come out in the solution if you don't worry about that. You'll just end up with a zero-sized array if C, in fact, is got a size of 0 or it's empty. No need to set msize equals 0 for the reason we just talked about above. And down here, this is also overkill. There's no need to allocate an object of size c.size, only to then turn around and blow away what you initialized m-element data to with the new object by calling c.toArray. That's duplicative and wasteful, so please don't do that. And also, you don't need to add msize to csize since it starts out at 0 above. You can just go ahead and say msize equal csize. Here's another issue that's not really a mistake. Just get in the habit of writing more streamlined code. Rather than saying if msize equals 0, return true, else return false, just say return msize equals 0. That's the idiom that most Java, C, C++, C#, and so on programmers would expect to see. Lots of issues with index of. So first of all, please get in the habit of using for loops, not while loops, because they consolidate all the initialization and the checking to see whether the loop condition is done and the incrementation in one place. Also, please don't call get here. That's unnecessary. Get does a range check. There's no need to do a range check in this case. And this particular piece of code is actually buggy because if it turns out that O is not equal to null, then if O equals null, equal null, then this code will be run, and if for some reason this code doesn't find what it's looking for, it'll then go ahead and run this code, and then since O is equal to null, O.equals will end up crashing the program, since it'll be trying to call a method through a null reference. So make sure that you properly handle this case by having an else and only doing this if O is not equal to null. So very important, subtle thing. We'll probably fix the unit test to catch this bug in the future, but I caught it visually because we didn't have the tests catch it automatically yet. Some other issues here with index of. This is a very clever approach using Java streams, so hats off to trying to take the plunge to do streams, but this implementation is way too complicated. Once again, you need to split out the case where the O parameter is null from the case where the O parameter is not null, and then simplify the code accordingly. This code is unnecessarily complicated. Yet more problems with index of. So rather than having these two loops, which will again be called needlessly twice, you need to first check if O is null and then do one of the loops, otherwise do the other one. And if you make this check, then you can get rid of all these checks to see if m element data equal null and O equal null. And then down here, same kind of thing. You shouldn't be checking if m element data sub I not equal to null and then calling m element data sub I dot equals. Just swap the order in this case so that you say O dot equals m element data sub I. And that way, once you know that O is null, you never have to worry about that causing problems. Here's yet some more common problems. I had hoped people would have fixed this from my comments in the frequently made mistakes video from assignment 1A, but apparently some people haven't gotten to that point yet. We will definitely mark this off if you don't fix it for the final submission. So don't have a single loop, have an if statement and then these two loops. it says here there should only be a single check for null in this entire method. That's not quite right. What I should be saying is you should first check whether O is null, and then once you know that, then you can have two different loops. One of those loops, of course, can be checking to see if M element data sub I is null, but you won't be doing extra checks the way we do here to check if O equal null or O not equal null every time through the loop. That code can be hoisted out and done just one time. Couple of problems with add all here. So please don't use iterators. Use the system.array copy. And this person's code was failing because they weren't taking into account the fact that what array copy expects is an array, and what's being passed in here is a collection. So if you fix that, then that code should work properly. People were doing some rather wonky things with calling ensure capacity internal by taking m size and multiplying it by 2, which you should not be doing. Just add 1 to m size. Likewise, another common thing I saw where people pass in 1 here. Don't do that. Pass in m size plus 1. And when you sit down and think about this carefully, you'll get a feeling for why you need to do it that way. Likewise, probably not a good idea to call ensure capacity internal with m size. You want to say m size plus 1 because you're going to be adding an element. Here was a really odd implementation where they check to see if m element data equal empty element data, and then go ahead and make a new unsynchronized array. That just makes no sense whatsoever. That has no meaningful purpose. So please rethink what you're doing. The key point of this whole checking to see if m element data equal empty element data is to be able to implement the semantics of default constructors for the unsynchronized array. And this way of doing things for the default constructor uses an idiom that's very popular in the Java development kit and the JDK. It's very popular in Android, where when you make a default object, it doesn't actually allocate the memory in the default constructor. Instead, it arranges to do it only when you do an operation that will cause that object to be used or needed, such as, say, adding something to an array. And so that's what's sometimes called lazy initialization. So it's a very common idiom. Not necessarily how you would do it in other languages like C++ or C, but it's very common in Java. I'm not sure what's going on here. This looks way too complicated. There's nothing to copy because if m element data equal empty element data, doesn't make any sense to copy anything because it's empty. Some other things people need to be careful of. Please don't use magic numbers like 10 or 20. Make sure you use symbolic constants like default capacity or extra room or whatever you want to call these things. I don't think you need this new size equal 20 stuff, but for sure don't use magic numbers. That's just a recipe for confusion down the road. And this this implementation doesn't properly handle the default capacity stuff, so make sure you're handling that correctly. The new versions of the unit test will hopefully detect these mistakes and flag them, so you'll have to fix them or your test won't pass. Once again, please don't use magic numbers like 20. And you also don't need to use a loop in ensure capacity internal. You should just be able to have a single operation that will do the appropriate thing, such as doubling the length or doubling the capacity. So it's pretty easy to do this with just a single statement. So make sure you do it that way. Lots of weird things with replace all. So replace all is actually one of those few places in all the code here where you actually really need a loop, a for loop, and in fact you need an index-based for loop, not a for each loop, not another kind of loop, but you need a index-based for loop. And this particular code is a good example of this. If you use an iterator, there's no way to set the value that you're going to be replacing. You'll notice here we call element equal operator.apply element, but that doesn't actually affect the underlying contents of m element data. So that's what you should be modifying, not this. This makes no sense. It won't do anything and you'll fail the tests. Again, replace all. You don't need to be calling the iterator here. You don't need to be checking if m element data sub I equal null, because that shouldn't be checked for in this way. And also, please don't use your set and get operations in this way. Set and get are really intended to be used by clients of unsynchronized array, where the index that's passed in to set or get isn't known to be in bounds, so we have to do a range check to make sure it's in bounds. In this case, we know that index I is in bounds because we're iterating for I equals 0, I less than m size. So we don't have to worry about range checks. So in this case, work directly off of m element data sub I for both setting and getting. Don't use set and get. That's overkill. For here, for the for each method, make sure you use method references instead of lambda expressions. This is, of course, for the grad student version for 1B. Here's another mistake. You don't ever want to loop for I less than m element data dot length. You want to loop for I is less than m size. M element data dot length can be full of garbage values that are not in consideration because they're all not accessed by m size. M size is the number of active elements in the unsynchronized array, whereas m element data dot length is the length of the capacity of the array, and those are two different things. Here's another problem. This is the for each method. This should conform to the specification, which expects a for each loop. This is using an iterator. This actually works, but it's not meeting the specification. The specification wants a for each loop. Down here, why is the iterator being called? I don't know. It's not being used. This implementation is also incorrect. It doesn't need to call toArray. There's no need to create the new array. What you need to do to learn how this works is to go watch rewatch the Java Consumer Functional Interface video, which shows you exactly the code you need to write to do this. Same problem here. We're iterating through the array for m element data. That's incorrect. You only want to iterate through things that are in the range, and m element data will most likely include lots of stuff that isn't actually part of the active range of the unsynchronized array. Once again, don't be calling get here because that has unnecessary range checks. Down here, I'm not really sure what this is trying to do, but it's overly clever by 1.5 because, once again, we're not using m element data. We're only using the range from 0 to m size, 0 up to but not including m size. And then the iterator is called here. That makes no sense. Don't have that. I think that's just to pass the tests, but you don't need to do that if you do this correctly. Here's a factory method, iterator factory method. I'm not sure what this is doing, but it's too complicated and it's incorrect. The actual solution is super duper simple, so think about how that works. For some reason, the person was defining the fields of array iterator in all caps, which is kind of like someone yelling at you. So please don't do that. It's inconsistent with the rest of the code. Follow the code conventions. And also, it's not strictly necessary to initialize this to 0, since that's the default value for ints, although it doesn't hurt if you want to do it that way. The next method in the iterator needs to advance the index, so make sure you do that, otherwise it won't iterate any further. Here's another issue with the next method. So either make the check to see whether or not the index is in bounds, and if it's not, throw the exception as done here, and then go ahead and access the element, the next element, using m element data directly, or use the get method and surround it with a try catch block and catch the index out of bounds exception, and then throw it as a no such exception, no such element exception in the catch clause. Don't mix them like this. This makes things unnecessarily inefficient. A lot of issues with remove. Please don't use a loop here. Actually, I take it back. This is in the wrong place. Don't call the remove method at all, or don't call the remove. Don't remove things. Maybe it was right before. Hold on. There we go. Yeah. Instead, call unsynchronized array this remove. That's what you want to do here, not doing system array copy. You want to use the remove method that's defined as part of the array class to get rid of the element, and you'll have to figure out which one to get rid of course. Also, make sure that you don't use this implementation of remove to indicate that you've removed something. So the idea here is that prev pause, or whatever you want to call this in your implementation, that needs to be set to a value that's less than 0. and simply decrementing it by 1 is not necessarily going to do that. So this will be checked better in the next skeleton unit test. And what we do is we make 2 consecutive calls to remove. The first one should work if done properly. The second one should get the illegal state exception, because you can only call remove after you've called has next and next. So you need to guard against that. Also, please get in the habit of using things like index minus minus or index plus plus or minus minus index instead of using index equals index minus 1. Good Java, good C++, C programmers, C# programmers will think ill of you if you use that format, because that's just not the way you do it. Let's take a look at the Splitterator implementations. This is something that done by the grad students for this implementation. Undergrads will have to do this for the next assignment 2A. In this case, you don't strictly need to set origin to 0, although it's okay to do it if you want. And, whoops, this is, oh, in this particular case, you don't want to set this to -1, since that's set in the constructor. If we were to look at the constructor, it does that. So you don't have to mimic or duplicate what's in the constructor. Make sure you pass the right value to the array splitterator from the splitterator factory method in unsynchronized array, and it shouldn't be -1. I'll give you that hint. It should be something else that's more intuitive. And then the last thing here is make sure that you don't try to compute the mid unless mpos is less than mn minus 1. And so basically the way that try split works, for those of you doing the grad student version, is if there's one element left, then you return null. Otherwise, if there's more than one element left, then you go ahead and compute the midpoint. So you need to have some conditional logic in there to differentiate between the case where there's one element left and the case where there's more than one element left. And this code wasn't working because it wasn't taking them into account. So those are the things that I saw during my walkthrough of everybody's code. Some people did extremely well. Great job. Well done. Thank you very much for being thorough and systematic in your implementation. I really appreciate that. Other people have a lot of things to fix, so hopefully this video will give you some pointers on how to make things work properly.